Welcome back to the deep dive. For centuries, conflict was defined by something very physical.
Kinetic solutions.
Exactly. The simple idea of taking a solid object, usually steel and just, accelerating it very fast toward a target. It was all about mass and momentum.
And impact.
But the sources you shared with us, they map out a really fundamental pivot. We seem to be moving away from that kinetic dominance.
We are. We're moving into an era where the most effective tools are often non-kinetic.
Things like energy beams, focused sound, even, robotic decision-making.
That's the new landscape.
Okay, let's unpack this. Today we're doing a deep dive into three interconnected emerging frontiers. First, directed energy weapons, then the world of non-lethal tech, and finally, the thing that ties it all together, sighting systems.
And that shift from a physical projectile to pure energy, that's the core concept. For military planners, the goal is twofold.
Okay.
Hit the target instantaneously and do it for a minimal cost per shot.
And that's the promise of direct energy weapons, or DDW.
Precisely. Often just called beam weapons.
So when we talk about instantaneous speed, what does that really mean in an operational sense? Is it just hitting a stationary target faster, or is there a bigger advantage?
It's the strategic advantage that's key, and it's mostly about countering really high-speed threats.
Like missiles or drones.
Exactly. When you fire a bullet, you have to calculate lead time, wind, gravity, the target's movement.
Yeah.
But if your weapon is a beam of light,
It gets there at the speed of light.
right, there's virtually no lead time calculation. You just point and you hit.
Yeah.
It fundamentally changes the problem.
So how are these DWs categorized?
Well, we could look at three core types based on how they deliver that energy.
Yeah.
First, the one everyone thinks of, laser-based systems. These use focused streams of photons to deliver a massive amount of thermal energy onto a tiny point.
So you're basically just burning a hole through it.
You're causing structural failure through intense localized heat, whether that's a drone's wing or an incoming mortar shell.
So if the laser is the thermal solution, what's the counterpoint that attacks electronics instead of the metal?
That would be the second major category. High-power microwaves, or HPM systems.
HPM.
Instead of focused heat, they produce these intense beams of radio frequency power. They're not designed to physically damage a ship's hull.
So what are they doing?
It's pure electronic warfare. They induce huge voltage spikes in circuits and antennas. They overload and, they fry the internal electronics of a system. It's an anti-command and control weapon.
And the third type?
The third is charged particle beams, CPBs. These are systems that accelerate streams of atomic or subatomic particles.
So not photons, but actual particles with mass.
Tiny amounts of mass, yes.
Yeah.
But striking the target at nearly the speed of sound. It gives you a devastating high-velocity impact, but critically, without a shell, a casing, or an explosive warhead.
That makes perfect sense for logistics. But the source material also mentions a specialized fourth type, the chemical energy laser. It sounds really powerful. Why isn't that the dominant choice?
The logistics, it's an almost impossible trade-off. Chemical energy lasers get their power from volatile chemical reactions, like combining hydrogen and fluorine. The energy output is phenomenal, but they require complex plumbing and huge tanks of highly toxic gases.
So they're just too difficult to handle and deploy safely.
Exactly. Especially compared to a system that just needs electricity from a generator.
Yeah.
The toxicity makes them risky and highly specialized.
So we have these instant strike, high power solutions, but now let's shift gears completely away from destruction and towards control.
A very different philosophy.
Right. Non-lethal weapons, or NLWs. These are designed to incapacitate people or equipment, well, this is the crucial part, minimizing fatalities and permanent injury.
It's about de-escalation, retaining control without causing a catastrophe. And the sources define this whole area by what they're designed to stop. They use 4 anti-categories.
Okay.
You have anti-sensor devices like low-energy lasers that just temporarily disrupt a camera or someone's vision.
Yeah.
And you have anti-mob solutions for stopping crowds or vehicles.
And the HPMs we just talked about would fit in there too, right?
They would, under anti-command and control for taking out a drone's brain. And finally, you have anti-infrastructure, which targets the physical support systems.
Looking at those anti-mob technologies, some of them are just wild.
They're very creative solutions.
Take sticky foam. It's fired from a device, and it creates this huge polymeric barrier.
20 feet wide in seconds.
And it just stops movement completely. An instant, non-lethal entanglement.
Or you could look at auditory deterrence. Acoustic weapons use extremely low frequency sound.
And the goal isn't to damage hearing.
No, not at all. The waves are tuned to induce a powerful physical effect. Intense nausea, disorientation. It forces people to disperse without firing a single shot.
Then there's the vortex weapon. The source material calls it an acoustic cannon and says it feels like being hit by a heavy blanket. How does that even work? How do you get physical force without a physical object?
You're creating an extremely powerful, focused pulse of air, a shock wave. It's a localized, non-penetrating transfer of mechanical energy.
So it's like a punch made of air.
A blunt, painful impact that incapacitates and frightens, but without the danger of shrapnel or penetration that you'd get from a traditional round.
And for anti-infrastructure, the sources mention liquid metal embrittlement. That sounds like something out of science fiction.
It's a very targeted form of degradation. It uses supercorrosive agents that destabilize the molecular structure of metal or glass, causing rapid, catastrophic failure.
If we connect these non-lethal ideas back to directed energy, we get to one of the most debated technologies out there, pain beams.
Officially known as active denial technology. And the mechanism is brilliant because it exploits our most basic defense mechanism, pain.
How does it do that?
It emits a narrow beam of electromagnetic energy, very high frequency, that is tuned specifically to heat the water molecules just under your skin.
And the depth of that heating is the critical safety feature, right?
Absolutely critical. The beam only penetrates to a depth of less than 0.04 centimeters. It's just instantaneous, intense surface heating,
So it creates an immediate, agonizing, burning sensation.
which forces the target to instinctively move away. Tests show the pain threshold is reached within 3 seconds. But because it's so shallow, the risk of permanent injury is minimized.
That discussion on necessary speed, it leads us into a much more difficult conversation. Lethal autonomous weapons systems. Laws.
The killer robots.
These are the systems that can find targets themselves and engage them.
Right, but it's important to understand that autonomy is often a technical necessity before it's a moral question. Think about defensive systems.
Like the phalanx on a ship or the iron dome.
Exactly. They have to react to incoming missiles in milliseconds. A human-in-the-loop detection, decision, engagement is simply too slow to stop a hypersonic threat. Autonomy, in that case, is required for survival.
So for defense, it's a requirement. But what happens when that autonomy shifts to offense, like the UK's Tyrannus drone? Where is the line drawn now?
The line, for now, is the final trigger pull. The sources are clear that even with highly autonomous offensive systems, current policy usually mandates a human operator for the final command to attack.
The human in the loop.
It's the last layer of safety and, more importantly, of accountability.
And that raises the big question, doesn't it? If that machine makes a tragic mistake, who is accountable?
That is the core challenge. This raises an important question. If we remove human emotion, nuance, fear, proportionality from the battlefield, how does a machine handle situations that need judgment, not just speed? The lack of accountability, it remains the largest obstacle.
A profound point. We've talked about these incredible future weapons, but none of them work if you can't point them correctly.
Which brings us to our third frontier, the practical reality of sighting systems.
You can have a speed of light weapon, but if your sight is off by a fraction of a degree, you miss.
Exactly. The humble sight is still paramount. We can basically organize them into two big categories: the classic iron sights and the more advanced optical sights.
Let's start with iron sights. The simplest is the open sight, a V-notch, and a post. It's fast, but you're trying to align three things at once: the target, the rear sight, and the front sight. Errors are common.
But the invention of the aperture sight, basically just a small circular hole, it solves that problem so elegantly.
Ow!
The human eye has a natural tendency to want to look through the center of a small hole. So the sight picture automatically centers itself, which dramatically reduces alignment errors.
And that's also why it's so good in low light, isn't it?
Precisely. You can adjust the aperture size to match your eye's pupil, which optimizes the light coming in. It's a simple mechanical fix that works with our own physiology.
Okay, now let's move to advanced sights, optical sights. These use lenses to put the target and the aiming mark, the graticule, on the same focal plane.
And their huge advantage is, of course, magnification. It's non-negotiable for snipers, for anyone trying to extend their range.
But magnification has its downsides: fragility, fogging up.
And parallax, that's a critical one. It's where the alignment between the reticle and the target shifts if you move your eye even slightly off-center. High-quality optics have to be engineered to mitigate that.
Then the final type is the lensatic sight. This one's interesting because it offers zero magnification. Why would you want an advanced sight that doesn't magnify?
for situational awareness. By keeping the view unmagnified, a user can aim quickly while keeping both eyes open, staying aware of everything happening in their peripheral vision. It's all about speed of engagement over long-range precision.
So, to bring all these ideas together, let's use that fascinating example from the sources, the sound bullet.
Right. Picture a tense crowd control situation. Instead of rubber bullets or tear gas, you could deploy a microwave ray gun.
But one that's optimized for an auditory effect. How does that work, especially if people are wearing earplugs?
And that's the genius of it. The microwaves pass right through the skull. They're sensed by the inner ear itself, the organs for balance and hearing a sound. The ear canal is completely bypassed.
So earplugs are useless.
Irrelevant. It generates a loud, disorienting sound inside the person's head.
That's a perfect illustration. It's crowd control using directed energy to cause discomfort and shock, but without causing permanent physical harm.
An effective sound bullet.
So let's distill this for you, the listener. What are the key takeaways from this deep dive?
Let's run through them.
First, directed energy weapons lasers, HPMs, CPBs, they offer instantaneous delivery at a low cost per shot, making them ideal counters to high-speed threats.
Second, non-lethal weapons, like sticky phone and acoustic devices, are all about incapacitating without killing, giving forces more options for control in complex situations.
Third, pain beams use active denial by heating the skin to a depth of less than 0.04 centimeters. It's a powerful, non-lethal psychological deterrent.
Fourth, lethal autonomous weapons are driven by the need for speed and defense, but they open up huge, unresolved ethical questions about accountability and human judgment.
And fifth, for aiming, the aperture sight is preferred for its self-centering accuracy, while optical sights are essential for the magnification needed at long range.
Pretty good summary.
Now, here's a question for you to mull over. If an aperture sight automatically centers the picture and works so well in low light, why do so many armed forces still use the simpler, error-prone open sights on basic weapons like submachine guns? Think about the speed of just getting the weapon on target and the need for peripheral vision in a very close-in fight.
These new frontiers force us to constantly weigh the trade-offs between speed, cost, effectiveness, and of course, moral responsibility. Thanks for exploring your sources more deeply with us.